Hello everybody and welcome back to the AIEX platform. In this video we're going to create a CV model to detect corrosion in images. This is the first video in a series to showcase the power of a specialized AI and the tools that the AIEX platform provides for you to leverage it in your industry. So let's dive in. Here I have a corrosion dataset containing 36 images of corroded objects. The more images we have in our dataset, the more accurate our model will be. So let's add more images. There are a few options to do so. You can upload images, upload videos, use the image engine to find images based on keywords, import another dataset into this one, or upload images from a URL. Let's try the image engine. We're looking for images of corrosion, so I'll type that in. The image engine found us a number of images. Let's add 3 to our dataset. This one looks fine. This one too, and also this one. Don't forget to click on Done. And now we have added 3 more photos to our dataset. The next step is to define corrosion for our CV model by putting annotation boxes or polygons around the corroded parts in the images. Once we have annotated an image, we send it for quality control. And when the quality of the annotation is inspected, it will be ready for use in training. AIEX features the task management tool, which makes it easy to manage annotations and the subsequent quality checks for bigger teams working with huge datasets. As you can see, the 36 images in the dataset have been annotated by a member and checked for quality by another member. I'll add myself and take responsibility for the new tasks. I will also assign myself for QC and take the 3 remaining images. Now all the tasks are assigned and we can close the management window. So let's start working on the new images. Clicking on an image will open it in the editor where you can use the polygon tool to create annotations. Just try to encircle the areas of interest and finish exactly where you started. After drawing the polygon, we choose a label for our annotation. In this dataset, we have defined just one category, which is corrosion, so we select corrosion. Don't forget to save your work. And if you're happy with the result, mark it ready for QC. Let's quickly annotate the other 2. Okay, since I'm also taking care of quality control, I'll take another look at the annotations and mark them ready for training. Now all the photos are ready for the next stage. The AIEX platform also provides a few tools to improve the size and the quality of our dataset and build a train-ready version of it. Click on the Build New Version button, and in the window that opens, choose a name for the training dataset and click on Next. Image tiling lets us break larger images into smaller tiles using a few methods to increase accuracy. Next, we have image augmentation, which creates variations of our images. For instance, if we choose a vertical flip, the flipped version of our images will be added to our dataset, and the resulting model would be better equipped to detect objects of interest in various orientations. We'll choose a few of these augmentations. Next, we choose what percentage of the images should be used for training the model, what percentage of them are used by the model to validate itself, and what percentage is kept from the model and used for testing it in the end. We want the model to use most of the images for its training and keep some of the images for validation and testing. So 70%, 20%, and 10% should be fine. If some of your images don't have annotations because they don't contain the objects of interest, then including them as false positives by toggling this switch will improve the training. The last step shows a summary of the improvements we are applying to our dataset. Click on Build to get ready for training. When AIEX is done building the train-ready version, we can see it in the Train tab and set it up for training. For segmentation projects, AIEX provides training algorithms from these frameworks. For this project, we are likely to achieve good results with the UNet algorithm in the NVIDIA Tau framework or U2Net from PyTorch. Let's go with U2Net. We choose the basic training parameters. Let's have 10 batches and 10 epochs. If you are an advanced user, you can also set the advanced hyperparameters for more control over the training process. Okay, let's start training our model. Training will take some time, so let's skip ahead a little bit. AIEX has now finished training our new model with our dataset and based on our configurations. If we are satisfied with the metrics of the model, we can deploy it with a click of a button from this menu to start getting inferences from it. In the Deployments tab, you can access the inference window through this little menu on the far right. We'll drag a number of photos inside it to see how our model does in detecting corrosion in images. As you can see, our new model has successfully detected the corroded parts in the images. Through the same menu, you can also download the model or use the API to access your model from other applications. Okay, that's it for today. In this video, we've seen how we can create a computer vision model to detect corrosion in images. In future videos, we'll show you how you can leverage the power of AI on the AIEX platform for various other use cases. Thank you for watching and see you soon.